This is the Chapter 1 video for Physics 1301. The topic is models, measurements, and vectors. Goals for the chapter to understand the units and measurements and specifically talk about vectors and graphing, adding them graphically and analytically, and how the x and y variables are independent of each other. Physics is an experimental science, so it's important that we follow the scientific method in terms of our investigations, and this always hasn't been the case. Here you see the Leaning Tower of Pisa there in Italy, and it's actually the hometown, well, they claims to be the hometown of Sir Isaac Newton, Galileo. But I remember when we were there in 2016, we were in fact in that cathedral right there, and we had just come from Florence, and Florence claimed Galileo. And I asked the lady here, because within this church here is the Galileo chandelier, which was the chandelier that the actual one that was there when he attended church there, that was swinging in the rafters and helped him develop his some of his theories on pendulum motion. She's explaining that to us, and I said, well, I have a question. Yesterday, the people in Florence told us that Galileo was from Florence, and oh man, I thought I was going to have to run out of the cathedral because they took that personally, because they claimed that Galileo is from Pisa. The reason I bring his name up is Galileo is prominent in taking science to the next level of going from accepting thought experimentation, thought reasoning that was prominent at the time of Aristotle, 300 BC, who was, a brilliant philosopher and tried to reason out why things happen, but often his observations were not seeing the entire picture. And so whether it be his two laws of motion, violent and natural, or whether it be his geocentric theories as to the Earth being the center of the universe, to circular paths for the planets because they're heavenly bodies and made by God, so they must be perfect, and a sphere is perfect and a circle is perfect, so they must be in those things. All of those things that Aristotle said were they were logical at the time. But here the story goes that Galileo went up to the Leaning Tower of Pisa and dropped two balls of two different masses, which Aristotle said the twice as heavy, massive one would fall twice as fast, and Galileo disproved that by doing experimentation. And that's significant. That's a significant step, and one that we should make note of. By the way, when we were there, we inquired as to what it costs to travel up into the Leaning Tower, and if you get there early enough, you can. And it was something like $7,500 a person. It was a ridiculous amount, and there were people going up it like it was nothing, and I just amazed me. We just got some pictures, and that was enough for us. Units of measurement. In this course, we'll use the metric system. One of, I think, 3 countries that use the metric system, or don't use the metric system as our go-to, but that is what we'll use. And the fundamental units that we use a lot of for time is the second, just as it is in either system. Length is a meter, and mass is a kilogram. The second used to just be tied to a length of the day, and then, but now it's tied to an atomic clock, which is that number of oscillations of a cesium atom, and so it's a very precise measurement now. The meter original definition was 1/10,000,000th of the distance from the North Pole to the equator. That has been redefined. Now it's tied to a krypton discharge and counting a certain number of wavelengths. What's important to know is that it is the standard that is everything else is related to. There used to be the kilogram in the Système International in France. Here's an image of that. But they even now have redefined how they determine what the kilogram is. It's important that you know how to convert between the meters to kilometers to nanometers and whatever. There's a list of those here that are ones we use more often. Obviously, the millimeters or centa, kilo. Your generation much more familiar with mega, giga, and tera, and just because of computer processing and the speed of transmission of signals are used there. But in the smaller scale, micro, 10 to the -6, nano, pico, and femto are all very small values. This gives a comparison between what we're talking about with those sizes. Be able to convert. Most of you have a math background that would probably, at most, you just need to do a little review, a little practice. There are tutorials out there that could help you with this, but that's up to, depending on where you are in your situation. Derived units are units that are a combination of multiple variables or values being combined. So the example here is for kilogram meter squared per second squared is the unit for mass and times a distance over distance times a meter per second squared, which is acceleration, and that is essentially a joule, which is a Newton meter, and that's a derived value that is simplified and referred to as a joule. Again, review those important skills. Some of the more common conversions: 1 inch is 2.54 centimeters, 454 grams is a pound, and 1 liter is 1.06 quarts. But you also 2.2 kilograms is a pound, or 1 kilogram is 2.2 pounds. Excuse me, I said that backwards. Here's the old, we used to call that fence posts, or the conversion factor label method. It's sad nowadays. I even did it myself not long ago. I needed to convert something from one unit to another. I think I was going from kilometers per hour to meters per second, which, I've had times where I've had that conversion factor when I've been practicing a lot in my head, and I ask Siri, and she gives you the answer almost instantly. But that's where we're at with technology today. Precision and significant digits. There's some rules about that are given in terms of significance, meaning, do I count that number? Does that number, was it really measured, or was it rounded off? And you remember the significant digit rules. If it's a non-zero, then it's significant. If it's a zero, or excuse me, if it's a zero at the end, right of the decimal, then it's significant. If it's a zero just as a placeholder, then it's not significant. If it's a zero in between two significants, it's significant. Review those rules as well. Vector addition, we're showing here that can put the vectors that you're given head to tail and add them graphically, and they will come out to give you the resultant, regardless of the order in which you put them in. However, we also can use, and this is the more practical method we use, is using the trig functions and establishing the adjacent side, the opposite side, the adjacent side here being the horizontal, the opposite side being the vertical, and establishing the A as being the resultant, and using the trig functions to solve those equations. And that is the more practical way, because it's more precise in terms of using those numbers rather than the act of physically drawing them out. So this is Chapter 1. Thank you.